some of you, well, first of all, who's first time out here? Okay, so we have a few people that haven't been out before, and the rest of you guys that just have been out here at least once, maybe some even twice. But this, once again, this is Project Utility, which is a combined project with the Michigan Department of Natural Resources, Michigan State Extension, and also the two partnership schools, the International Technical Academy of Pontiac and Detroit Detroit Preparatory High School for Math and Science, but they were unable to be with us today. Well, for you guys who don't know the players here, I'm going to have everybody introduce themselves. I'm Michael Napier. Over in that corner behind Ms. Donahue, we have
Harris Lloyd, I'm the park manager here.
Okay, and then in the corner in the top.
I'm Gary Williams, Michigan State University Extension.
Okay,
And I got a law staff member.
and that's it from the steering committee. Now we're fortunate today to have a guest, a consultant here with us, because you guys have been studying solar energy. So what we have here is Mark Kreiderman, who's with Green Panel Incorporated,
Yes.
which is a solar company here in the Brighton area. And Mark's going to talk to you guys about solar energy, and I'll let him have the floor. Mark, your students.
Okay, so my name is Mark, and the Green Panel is a company that is a solar installation company. So we don't make solar panels. What we do is design systems, and then we go purchase the components, the solar panels and the racking and the inverters and so on, and then we make installations. And we do it at commercial sites, at universities, at a lot of residences, wherever. So that's what we're about, and so that's what I'm here today to kind of run you through what we do. So as a salesperson or an engineer, when you go out to a site and somebody wants solar, there's a whole lot of things to look at, and I'm going to run you through how we do that so you get a little bit better picture. Does that sound okay?
Mm-hmm.
Yes.
All right, and you all know a little bit about solar already?
Yeah.
Studied a little bit about it? Okay. So I have my little mini solar panel here, okay? I don't know how many of you have actually had hands-on with one. This is a little section of one, okay? It doesn't work, but it's the one. It's actually 4 cells. 1, 2, 3, 4. Okay. A regular solar panel is about 5 feet by 4 feet, and it has 60 cells in it. 60 of these. Okay. Solar panels are made all over the world. These cells here are only made by 3 or 4 companies, and then everybody else buys these cells and makes a panel out of them. So when they say they make a panel someplace, all they're doing is taking these components and putting them into a big solar panel. So it's not a complete assembly facility, but it's very easy to start one up. So you take these cells, you put some glass on the front of them, to withstand 60-mile-an-hour softball-sized hail. You build an aluminum frame, and you put this on here, which is the connection. This is the electrical connection. Solar panels are really easy to put up out in the field because they all have these connectors. So all you have to do is just a push and connect. Okay, and they're all connected up. So the easiest part of solar is putting it in and installing it out in the field. The tough part is making sure that what you're doing is going to work and it's going to meet the customer's requirements. And that's especially true when it's off-grid like we are here, because there's no backup. You know, most of the installations we do, the people are already connected to the grid, and all the solar is doing, it's doing what we call net metering. So sometimes, like at night, they're taking power from the utility. In the daytime, they're producing solar, which may be powering them completely enough that they're actually sending power back to the utility. So it's going back and forth. Now, my own home is like that. I have solar power in my own home, and my home is designed so that over the year, I'll be what's called net zero. So I'll supply the utility as much power as they supply me, and so my electrical bill at the end of the year would be 0. That's the goal. Okay? But here we got a different situation. We're off-grid. So, what's the very first thing that you look at when you're going off-grid? And I'm coming in as a solar, or you're coming in as a solar person, what's the very first thing you need to know? Anybody know? Okay. Okay, the very first thing you need to know is, what are you gonna power? Okay, what is it? And in this case, you know, maybe you've already looked at it, but what are you gonna power here? Are you gonna power a couple of lights? I heard some talk about a well pump. You know, you have to figure out what those things are, because you're gonna have to design a system that's going to power them reliably when they're needed. When is this being used? Okay, is it only being used in the summer? That makes a big difference, because solar isn't very strong in the winter. The days are short, there's a lot of cloudy days. So that would make a difference, because if it's in the winter and you're using this a lot, we would need a lot more solar to be able to meet our requirements, because we wouldn't be picking up as much every day from the sun. So you need to know all of this, okay? And when you learn all of this, you have to understand how much power is being used or required in amps, okay, amperes, okay? Watts equals volts times amps. So you're going to have to figure out what voltage the system is. Usually off-grid it's batteries. It has to be batteries. And it's either designed for 12 or 24 volts, okay, the way you hook the batteries up. So you know the volts. And then you have to figure out how many watts these things are using at that voltage. So it's a pump, some lights, okay, and you figure that out, and you're going to come up with amps, how many amps they're using. And then how many amps are they using per week or per day? How many hours? And now you've got amp hours. And once you have amp hours, then you can go to your batteries, because batteries are rated in amp hours. So if it's a 50 amp hour battery, and you need to draw 5 amp hours a day, it's going to last several days, okay? You also have to know with batteries, existing batteries, lead acid batteries, like in your car, or golf cart or whatever, that you can only take that battery down halfway. You can't take it all the way down to zero. If you do, it'll implode itself. You can only take it down to half. So if it says it's a 50 amp hour battery, you only got 25 amp hours that you can use. Okay? So once you know all of that, now you've got the batteries, and you know how many batteries you need, and once you know how many batteries you need, then you can backtrack and say, okay, to keep those batteries charged, this is how many solar panels I need. Okay? And then and that's it. And you've got a design. Then you got to figure out where to put them. Now, we have some issues here. What are the issues?
Trees.
Exactly. Okay. And we have one more issue here. I'm not sure it's an issue. Is we got to face roughly south. Okay, if we have, because that's where the sun comes up in the east and sets in the west, and it's in the southern sky. So we really have to be faced, ideally, south. Now we've proven that you can go quite a ways, east or west. In fact, if you go all the way east or all the way west, you lose about 20%, okay, of your power. You're going to get more in the evening, nothing in the morning, but you're going to lose about 20% overall. You don't want to go any more towards the north, okay? West or east is the farthest you want to go. Sometimes you don't have a choice, okay? I don't know the exact orientation of these buildings. Before we leave, I'll show you how we're going to figure that out. And I'll show you, maybe we'll do some small groups. I'll show you, I have a device here that it can actually tell us how much shading we've got from trees and that kind of thing. I've got about 20 of these, so maybe every other person. This is the basic design of a, maybe I'm repeating myself and you guys know all this. Can you help me? Every other person? Okay, I've got enough for every other person, I think.